goes from a negative first derivative to a positive first derivative, then that has to be a minimum. So the steps, again, how we do that one is we basically need to find the critical points and then just have to make a sign chart. Pretty straightforward, I think. How we justify our answers, you do have to clearly state that the first derivative is changing signs and how it's changing. So if we say that we have a relative maximum, that's going to be where we have a positive derivative, then a negative one. So then this is just review, but we say we have a maximum because this is f, so I'll say f prime changes from positive to negative, and that will always give you a relative maximum. Likewise, if you have a minimum, you have a negative derivative, then a positive derivative. So we'll say something like f prime changes from negative to positive. The one that I think is trickier for students to kind of just like understand like conceptually is this second derivative test. So the second derivative test still tells you whether you have a minimum or a maximum, but we use the idea of the concavity to figure out which way the function is kind of bending to see whether we have a minimum or whether we have a maximum. When I think about the second derivative test, the easiest way for me is at the concavity. That I can't spell concavity, let me try that again. So we're looking at the concavity at horizontal tangent lines. So the second derivative test does have some limitations. It only works when you have horizontal tangent lines. So whenever you justify using the second derivative test, you always have to state that there is a horizontal tangent there. And how do we state there's a horizontal tangent? You have to say f prime of that value is equal to 0. When you have a maximum, so you think we have a horizontal tangent, for this to be a maximum, the function needs to bend down, it needs to bend under that horizontal tangent line. So your second derivative would have to be less than 0. If we have a minimum, so there's my horizontal tangent line, the function needs to bend upwards for that to be a minimum. So it relies on you kind of knowing the first derivative and the second derivative. Don't have to make a sign chart for this one. Main steps is you need to first find when the derivative is equal to 0, and then you want to plug those values into the second derivative. And you'll have time to practice with both of those. That's kind of what the homework has you do if you haven't started it quite yet. But that does bring me to like the last kind of conceptual things I want to talk about without really doing any problems, just like talking about like what happens if we don't have a horizontal tangent line, or what does it mean if like the concavity, there is no concavity at horizontal tangent lines. Because these questions show up a lot. We know the AP exam has both multiple choice questions and free response questions. A lot of the questions dealing with the second derivative test are really going to be more like conceptual questions on the multiple choice part. So you kind of understand like when you can use it and when you can't use the second derivative. So when can you use the second derivative? Kind of going back in the notes, I have this statement. So the second derivative test can fail. One of College Board's favorite types of questions to ask students to kind of assess their knowledge on the second derivative test is it will say something like, here's some function, determine whether this function has a relative minimum or a relative maximum using the second derivative test, or if the second derivative test fails, explain why. So mathematically, when we say the second derivative test fails, that doesn't mean that there's no minimum or no maximum. It just means like we don't know. So I have kind of here in the black letters, if the second derivative test fails, like huge question marks there, like we just don't know what that means. It could mean that we have a maximum. We could have a minimum, or we could just have like some other weird thing happening. The only way you can use the second derivative test is if your first derivative is equal to 0 and your second derivative is greater than 0 or less than 0. If your second derivative is equal to 0, can't use it. If your second derivative is undefined, you can't use it as well. So that's kind of the main thing you want to get from the second derivative test. First derivative has to be equal to 0, and the second derivative has to be positive or negative. The second derivative test fails, meaning it's inconclusive, when the first derivative is basically not 0 or undefined, or, I probably should say there, like and/or, the second derivative is equal to 0 or undefined. And I have some diagrams on the next page, like I shared with you in OneNote, so you don't have to like draw them all. But often students are like, well, what does it mean if the second derivative equals 0, and how can we not tell what that looks like? But big main idea I want you to kind of pick up from today's notes is just like the second derivative test only works at horizontal tangent lines and when you know the concavity. If you don't have a horizontal tangent line, and if you don't know the concavity, then you can't use this thing called the second derivative test. So I'll give you a chance to write that down if you're writing that down, and I'll just show you. Next slide, don't really have to copy down. It's more just want to show you different graphs where I would say we can't use the second derivative if we didn't know what the graph kind of looked like. Anyone still writing that? So here's some, because I often students ask me like just different cases. So here's a function. So realizing in the calculus class, like you wouldn't know what the graph looks like. You would just be given the equation. In orange right here, I have an example where the first derivative is undefined. And so if the first derivative is undefined, do you realize you could use the first derivative test, like a sign chart would still work for you. The second derivative would not work because if you're looking here, in those three examples I gave you, like it could be a relative minimum, it could be a relative maximum, or you could just have no relative extrema. So you would have to rely on your sign chart to figure that out. You wouldn't be able to rely on the second derivative test because technically you don't have any horizontal tangent lines. The other types of problems you can't use the second derivative test is maybe you do have horizontal tangent lines, but the second derivative is undefined. We haven't seen many problems yet in this class where the second derivative is undefined. I try to come up with a few. They usually end up being like some weird, like rational power functions. But these are examples, like if you had just done the second derivative test, like there would have been no way to know whether you have a minimum, a maximum, or just nothing based off of the second derivative test. You would be forced to use the first derivative test. So in all these graphs, like this would be an example where the derivative is equal to 0, but the second derivative is technically undefined at that vertex. So we wouldn't be able to use the second derivative test. And then last case, here's one where they're both equal to 0. So again, the second derivative test doesn't work when the second derivative is equal to 0 because we technically don't know the concavity at that point. So like, here's three examples that have both a horizontal tangent line, but at that horizontal tangent line, there's also no concavity. So we wouldn't be able to know whether we have a minimum, a maximum, unless we went back and did the first derivative test. So that just brings us, I have two kind of quick examples I want to look at, but these are the tests we're going to use for relative extrema. Again, most of you should be pretty comfortable with the first derivative test because it's about the same steps as intervals of increasing and decreasing. The one I always find students have a little bit more trouble with is going to be that second derivative test. So last thing I wanted to do on your quizzes, that very last page had some where I gave you that first derivative and some people had issues with that. So I did want to just go over a few questions on that just to remind yourselves that like once we learn something in this class, it kind of never goes away. So here's a problem I made up, just kind of took a weird piecewise graph. And this might help you when you're doing corrections on your quiz, if you missed it. So this is the graph of h prime. So we are looking at the derivative. And I just have two follow-up questions. And again, some of the issues I was seeing was people like either just couldn't answer it correctly, or if they did answer it correctly, their justifications were not quite up to like the AP standards. So the first question I have, I'll make that a little bit bigger for those of you in person. I have, get there eventually. First question says, at what x coordinates does the graph have a horizontal tangent line? So let's remind ourselves kind of in calculus. What does it mean for something in calculus to have a horizontal tangent line? What calculus fact should be kind of screaming out in your head? f prime is equal to 0. We know that horizontal tangent line means that the first derivative specifically is equal to 0. Whatever variable we use to define it, we know the first derivative is equal to 0. Well, what graph are we looking at? We're looking at the derivative. So looking at this graph, at what value is the derivative equal to 0? Negative 2, and where else? And be careful, we're choosing negative 2 not because the graph has a horizontal tangent there. We're choosing negative 2 because the value of the derivative is on the x-axis there. So where else do we have a horizontal tangent line on the graph? 5. So x equals negative 2 and x equals 5. My reasoning would be because h prime is equal to 0 there. It's on the x-axis. And so then at those two x coordinates, we can kind of classify those technically as relative minimums or relative maximums. So these are basically our two critical points that we have on the graph. So let's classify them now as a relative minimum and as a relative maximum. Since we're looking at the first derivative, we can kind of think of this using the first derivative test. So at x equals negative 2, where we're talking about the graph of h now. As negative 2, would h have a relative minimum, a relative maximum, or neither, and how do you know?
Minimum. Yeah, because we're going to be horizontal.
So let's think about the first derivative test. If negative 2 is a relative minimum or a maximum, we should see that the sign of the derivative would change. Well, we're looking at the derivative, so kind of look at this graph like it's a sign chart. On the left of negative 2, do we have a positive or negative derivative, technically? So careful when I say derivative, you're looking at the derivative. It's above the x-axis, so it's positive. So remember, like, these are positive numbers. And on the other side of negative 2, it's still positive. So basically, we have a positive derivative and then a positive derivative. So is x equals negative 2 going to be really anything special? No. So we'll say something like it's neither. How do we know it's neither? Because the first derivative doesn't change signs. And again, this is coming from the first derivative test. Kind of using that idea, then at x equals 5, I do see something a little bit more happening there. Would that be a relative minimum, maximum, or neither, and why?
Minimum.
So think on the left of it, we have what types of numbers? Positive. So we have positive slopes, and then when it hits 5, it changes to negative slopes. So at 5, it's going to be going up first and then down. So what do we have at 5?
Maximum.
Relative maximum. So x equals 5 is a relative maximum. How do I know? Because h prime changes from positive to negative. Does that make sense? Maybe one more problem, and then I'm going to stop for today and let you work on homework. Points of inflection we talked about actually earlier. This actually is very similar to one that was on the quiz. So this is that same graph. We were looking at the derivative. So we're not looking at the graph of h. We're looking at the derivative of h. And I have the question as, at what x coordinates does the graph of h have a point of inflection? Sometimes I think it might help some of you to write your justification before you give an answer. What's the justification we would use normally to defend where a point of inflection is? What does that mean again?
Changes signs.
Where what changes signs? Which derivative?
That's double prime.
The second derivative. So we know that point of inflection is where concavity changes. So let's be specific. Point of inflection would be where concavity changes. That would be the second derivative. So we know we're looking for where the second derivative changes signs. But we're looking at the first derivative here. So we have to kind of think about how is that first derivative related to the second derivative. So if you were to pick one, let's just kind of see who can figure out where would the point of inflection be on h. Again, you're looking at h prime. Where would the point of inflection be if anyone wants to make a guess?
4.
At 4, I would agree with Sarah. I would say that there is a point of inflection at 4. What would be your justification you would use?
Increasing and then decreasing.
Instead of saying it, what are you going to say instead?
Because at x equal to 4, h prime is changing slope. What slopes?
I would say what you said first. Changes from increasing to decreasing.
Then it's still positive, so it's going to be.
And so remember with the point, so, and we don't have to really care, like, you could just say changes signs as well. Or actually say changes direction, like that would also be acceptable. And this goes back to that chart we did back in Unit 2, where we saw that, like, when we said when the second derivative was positive or negative, that meant the same thing as the first derivative was increasing or decreasing. So when I say h double prime changes signs, that's the same thing as saying h prime changes direction. Definitely go back and look at that chart from Unit 2 if you need that reminder of kind of how all those things are related.
So do you have to write both of those down? Or
One or the other. Since point of inflection don't really care, like, it's a point of inflection whether it changes from concave up to concave down or concave down to concave up. To me, it's easier just to say where it changes direction instead of it specifically. Especially if there's more than one, it's an easier way to say it. So what I want you working on today is basically the homework. And the homework you're working on is this relative extrema homework. Again, I just try to choose the numbers that would give you the best practice. Some of these do have a little bit more algebra into them than others. The ones on page 183 tend to focus on the first derivative test. You're going to be making a lot of sign charts. The 192 page is going to be focused on the second derivative. So some of you have a habit of maybe doing only half the homework. This would not be a good one to just do like the first half. You want to definitely make sure you do some problems from page 192. Looking at the rest of this week, I did, of course, have to adjust the calendar a little bit. Remember, I'm no longer giving you that quiz B in class. I'm going to allow it to be a take-home quiz, which hopefully makes it better grades for some of you. But I'm going to make that take-home quiz available on Friday. And basically that quiz will still cover Extrema. So what we have to do the rest of the week, we'll be looking at absolute Extrema tomorrow and Thursday. Friday will be like a work day / if you finish the homework, we can go ahead and start that take-home quiz. But y'all can go ahead and get started on the homework. Definitely ask me questions as you have them. Again, you should be working on that homework for relative extrema. You can also continue